Hey everybody, Mrs. Bianchi. A restaurant owner orders new plates and spoons based on the information below. Plates are sold in packages of 9, spoons are sold in packages of 12. The restaurant owner orders an equal number of plates and spoons. What is the least number of packages of plates and packages of spoons she should order to have an equal number of plates and spoons? So we're really talking about finding, when you see the word least, that's kind of red flag for you might be doing the least common multiple of the two numbers. And in class, we talked about two different ways that you might approach this. One way is to just simply list out the multiples. So when we think about multiples of 9, 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. And we could kind of keep going. Then you would think about your multiples of 12. 12 times 1 is 12. 12 times 2 is 24. You should have this on your piece of paper. 12 times 3 is 36. Now, do you see how right now we have a number that the two sets have in common? And this is the least that's a match. This is the least value that's a match in two sets. So that's one approach that we can take. But I do want to remind you of how we might use prime factorization to come up with the same answer. The numbers, when they're smaller, like 9 and 12 are lower numbers, and that's more manageable. But what if the numbers had been like 108 and 124? That would have been a total nightmare. So I do want to review how to find the LCM using prime factorization. So if we were going to do the prime factorization of 9, we would think of factors other than 1 times 9 that equal 9, and we might come up with the 3 times 3. Now, these are prime numbers, so that tree is done. If we'd gone on to the 12, we might have done like a 3 and a 4. We could have done a 6 and a 2. But let's look at the 3 and the 4. And we would have kept going until we have all prime numbers. So the prime factorization for 9 is right here. And the prime factorization for 12 is right here. Now, when you're using this approach, you would do a Venn diagram. So we would do two circles. And your prime factorization for 9 would go in this left circle. Your prime factorization for 12 would go in this circle. And if you happen to have any that are in common, then you would put them where the two overlap. So what do they have in common? Well, we have common 3's. So we would put them right here. And that's it, that's in common. By the way, that would be the GCF, which we're not looking for here. And that is an answer, and people will fall for it. So if you're finding the LCM, you would take any of the non-matching numbers and you would write those outside of the overlapping part, so that this 3 gets transferred here. This 2 gets put over here. I'll circle it, and then we wrote it down. And let's circle this and write it down. Now, to get the answer of what's the LCM of the two numbers, we would take all of these and multiply them together. So it's always a good idea, if you're super conscientious, to do it both ways to make sure you get the same thing. So if I were to just chunk this up, this times this is 9, and this times this is 4. And if I do 9 times 4, do I still get the same thing I got over here? And the answer is yes, we do get the same thing. So hopefully you can clearly see what the right answer is there, and you'll go ahead and bubble that in.